Hey everyone, this is Brandon. I recently came home from China. 110 hours of traveling, I had a few different flights, and I noticed that the airlines don't actually logically seat their passengers for social distancing. For example, on my international flight, they seated me right next to somebody while half of the plane was empty. While I tried to move to my own row, I was actually yelled at for trying to change seats because they wanted to track exactly where I was. A domestic flight in the US, I was actually in line trying to ask the flight attendant to give me a row to myself or a buffer seat if it was possible because I just traveled from across the world. Meanwhile, in front of me, there was a family trying to get their daughter seated directly next to them because it was just a random seating, the conventional way of airlines seating their passengers. So while I was in my self-isolation upon return, I decided to brush up on my Python skills as I'm looking for jobs. And this became a coding challenge that kind of mirrored a typical interview question of seating passengers on an airplane. So it would involve some sort of questionnaire to ask the passenger if they're in a group with people, if they have a pre-existing condition, and if they have a travel history. Didn't think that was much of a stretch to ask those questions, and then I built in a UUID so that their name would be anonymized anyway to comply with GDPR standards. As I'm thinking of my friends that are stuck in China that may not be able to return home because they're just closing more and more flight schedules down, and also thinking about restaurants and cafes and stores and bars that are trying to reopen right now to maintain our economy, I realize this problem is actually very applicable to a number of different problems right now as we're just trying to randomly guess, okay, let's open things up back at 50%. Shot in the dark. So I built this problem to generate random passengers, random ages, group sizes, and then give those ages a certain possibility that they have pre-existing conditions based off of health reports, just to kind of build in controlled randomness to the problem. Basically, that could be your training data. Test data would be the actual seating assignments that the algorithm gives. In reverse engineer, evaluate the success if you want to maximize the number of seats that you have for your older passengers with pre-existing conditions, or you want to maximize the number of passengers altogether that get the spacing around them. There's a number of ways to solve this. It's a very interesting optimization problem. It's actually a good exercise of how to not only solve a machine learning problem, but to build a machine learning problem. So I have everything posted up on my GitHub, made a little nifty animation to show at least one of the random data sets in action as it's seating the passengers. So the code I have running here is basically actual code in action. I started off with basically an input to tell me choose the option of the airplane model, and these are based off of the actual flights I was on. And then I also have pre-programmed a number of maybe 5 different offsets options, which the offset basically means the number of seats to your left and right, ahead and behind you that you're going to give this passenger. So it runs a theoretical maximum analysis to tell me how many passengers I actually can seat on this flight if each of them has this exact offset. So then that builds into a counter to understand, the ratio between seated passenger per buffer. As it books these passengers, it basically updates a counter to tell me how many more free seats do I have, the difference between the capacity of the plane, the full total count of seats, and the booked seats that are of the actual passengers on the plane. So as I go through, it actually tells me, okay, you're running out of buffer seats. You cannot assign this type of offset for this passenger. You're not going to be able to, give anybody else any buffers. But basically, at a certain point, at a certain capacity, you don't really have a choice. So how do you go back through and reassign, to give a certain passenger lesser buffer than they need? The runtime here, just 64 seconds, and that's with the actual analysis of those 5 offsets for this plane model. So I have it where it can run 1,000 times and save 1,000 CSVs, and then you would basically just need to go back and figure out how many times did a passenger with a pre-existing condition not get any buffer seats, and how can I prioritize based off of the way that I've built this into my code. And that's essentially what the point of the machine learning would be on top of this.